You didn't choose your eye color. Nobody asked you. Nature just rolled the dice before you were even born and handed you whatever it felt like. But here's the part nobody tells you. That random dice roll actually came with real, measurable advantages and disadvantages baked right in. And some of you got genuinely screwed. First, we got amber eyes. Around 5% of humans have amber eyes. That's it. Most people go their entire lives without meeting one. Here's what makes amber eyes weird and kind of cool. The pigment that creates that reddish-yellow color is called pheomelanin. It's the same pigment you find in animals, wolves, hawks, certain cats. Humans aren't supposed to look like that, but 5% of us do. Now here's a real advantage. Lighter eyes, in theory, handle darkness better. The logic is straightforward. Less pigment means less light gets absorbed before it reaches your retina. So a tiny bit more light bounces around inside the eye and gets detected. Think of it like turning up the sensitivity on a camera sensor. Does it make amber eyes superhuman in the dark? No, the effect is subtle, but it exists and it gets stronger the lighter the eye color. Drawbacks. Because there's less melanin in the iris, bright environments are harder to deal with. Glare is a real issue, and some studies have flagged a slightly higher risk of cataracts down the road. Not catastrophic, but it's there. Next is hazel eyes. Here's what hazel eyes actually are. Brown, green, and gold pigments thrown together in a patchy, uneven distribution across the iris. It's not a clean blend, it's more like tie-dye inside your eyeball. This creates something genuinely interesting. Depending on lighting conditions, your pupil size, or even the angle someone looks at you, different parts of the pigment catch the light differently. So the eye appears to shift color. Not because it actually changes, the pigment is fixed, but because uneven distribution means different things are visible under different conditions. People have called it mood-dependent color change for centuries. That's the mythology. The reality is just clever optics. The real consequence of this, hazel eyes can pull advantages from multiple directions. Depending on your specific mix, you might lean toward light-eye night vision advantages, or dark-eye UV protection advantages, or somewhere between both. The problem? It's completely random which mix you got. You could land on the best of all three. Or you could get the worst of all three. There's no guarantee. What is universal to hazel eyes is the social angle. The shifting appearance reads as exotic to most people, which consistently puts hazel in top-tier attractive eye color surveys across multiple cultures. Drawbacks: more glare sensitivity in sunlight, a somewhat elevated risk of certain cancers, and a slightly higher chance of age-related macular degeneration, which is essentially your central vision degrading as you get older. Next up, green eyes. Roughly 2% of the world has green eyes. 2%! That makes it one of the rarest eye colors in existence. Now here's where it gets genuinely strange. Green eyes are technically an optical illusion. There is zero green pigment in a green eye. None. What's actually happening is this: low melanin levels create a baseline blue tone inside the eye, and then yellow pigment layered on top of that combines with scattered light to produce what our brain reads as green. It's the same principle as how the sky looks blue even though the sky isn't actually blue. It's just light bouncing in a particular way. So when you look at a green-eyed person, you're not seeing a pigment. You're seeing physics. Because green eyes are on the lighter end of the spectrum, they carry modest night vision advantages over darker eyes. And their biological rarity combined with that striking appearance tends to make them land very high on attractiveness rankings globally. There's also centuries of cultural mythology around green eyes, luck, mystery, witchcraft in some cultures. None of that is science, but the cultural footprint is real. Drawbacks: higher light sensitivity means bright environments are uncomfortable. There's also an elevated risk of ocular melanoma, cancer of the eye, and a higher general skin cancer risk, because the low melanin count extends throughout the body, not just the eyes. From green, we move to blue, born from one person 10,000 years ago. Before blue eyes appeared, every human on Earth had dark eyes. Every single one. Then somewhere between 6,000 and 10,000 years ago, a single genetic mutation happened in one person, and every blue-eyed human alive today descends from that moment. That's not mythology, that's genetics. Blue eyes sit around 8 to 10% of the global population. Like green, the color isn't from a blue pigment, it's from light scattering inside a low melanin iris. Basically the same trick, slightly different result. The functional advantage of blue eyes is where it gets interesting, because there's so little melanin-absorbing light. Even the faintest reflected light in a dark environment registers. The eye is essentially running at high sensitivity all the time. In low-light situations, this is a genuine edge over darker eyes. Not night vision goggle level, but measurable and real. Socially, blue eyes consistently rank among the most attractive eye colors across cultures, which is partly rarity and partly that striking, high-contrast appearance against most skin tones. The cost of all that sensitivity, bright light is brutal. UV exposure is a significant concern. Blue-eyed people face a higher lifetime risk of ocular melanoma and higher skin cancer rates compared to their dark-eyed counterparts. You can detect more light in the dark, but the sun is not your friend. With that, now let's talk about gray eyes are held by roughly 1% of the population. That makes this the single rarest eye color on this entire list. Most people will never meet a gray-eyed person and not even realize it. Structurally, gray eyes work on the same principle as blue, very low melanin light scattering in the stroma. But the internal structure of the stroma is slightly different, which scatters light differently and produces silver tones instead of blue. It's a subtle architectural difference with a visually dramatic result. Some research suggests gray eyes may actually contain even less melanin than blue. If that's accurate, the logical consequence is that gray eyes might edge out blue on night vision sensitivity. It's essentially a more extreme version of the same mechanism. The effect is slight, but on a strict ranking of light detection capability, gray potentially sits at the top of all the lighter colors. The rarity and unusual silvery appearance consistently places gray among the most visually striking, and therefore socially advantageous, eye colors globally. Drawbacks, same family of problems as blue, just slightly amplified. Higher melanoma risk, skin cancer vulnerability, and the sun is actively hostile to eyes with this little melanin. Now moving to default settings, we got brown eyes. Half the planet has brown eyes, 50%. By sheer numbers, brown eyes are the most successful eye color in human history, and that's not an accident. Brown eyes are the original human eye color. Before any of the lighter mutations appeared, every human walking the earth had some version of brown or dark eyes. And there's a very practical reason that original version dominated for so long before anything else appeared. It works. High melanin concentration means brown eyes are essentially wearing permanent sunglasses. UV rays, absorbed before they can do damage. Glare, managed. Age-related macular degeneration. Brown eyes have some of the lowest rates of it. Ocular melanoma, also significantly lower risk. Skin cancer, lower. The list goes on. Brown eyes are just durable, protective, and low maintenance in terms of ocular health risks. But here's the one that catches people off guard. Multiple studies have found that people perceive brown-eyed individuals as more trustworthy and warmer on first impression. Not a small effect, a consistent, cross-cultural result. Brown eyes literally alter how strangers read your face before you've said a single word. Whether that's an evolutionary association with familiarity or something about the softness of the iris pattern, the practical upshot is the same. Trust is a social currency, and brown eyes generate it passively. The real drawbacks are two things: darkness and cataracts. High melanin absorbs too much stray light, which is great in daylight but means the night vision advantage goes to lighter colors. And some studies point to slightly higher cataract rates over a lifetime. But overall, the health profile of brown eyes is arguably the strongest single-color package on this list. One eye dark, one eye light, the theoretical best of everything. Heterochromia is the condition where someone has two different, colored eyes. Around 1% of people have it, making it about as rare as gray eyes. Most people know it as that cool thing some celebrities have. But what most people don't think about is what it actually means in biological terms, and that's where it gets genuinely fascinating. There are different types of heterochromia, but the one that earns this number 2 spot is complete heterochromia, specifically the version where one eye is dark and one eye is light. Think about what that means. The dark eye carries all the UV protection, melanoma resistance, and trust signaling advantages of a dark eye. The light eye simultaneously carries the low melanin light detection sensitivity of a lighter eye. One person, both advantages, at the same time. In theory, this is the most biologically complete eye configuration on the list. On top of that, the visual asymmetry is genuinely striking. Socially, people with complete heterochromia are consistently rated as unusual and memorable in appearance. For better or worse, you will be noticed and remembered. The one flag, heterochromia, that appears later in life, not present from birth, can sometimes indicate an underlying condition, so it's worth getting checked. Congenital heterochromia, the kind you're born with, is almost always harmless. And last, black eyes don't technically exist. What does exist is brown eyes so dark, with such a high concentration of melanin, that under normal lighting conditions they appear completely black. You cannot distinguish iris from pupil. That's what we're talking about. Around 10% of the global population has this level of pigmentation. So why does maximum melanin win? Because every health advantage that brown eyes have, black eyes have at full intensity. Best UV protection on the list. Lowest risk of all the ocular conditions, melanoma, AMD, glare-related damage, across the board. The melanin content is essentially a biological shield for the eye, and black eyes have more of it than any other configuration. The only real drawback is the same one brown eyes have, just amplified. Low light performance. All that melanin absorbs stray light so effectively that night vision takes a hit. If you have black eyes, someone with gray or blue eyes technically sees better in the dark than you do. But here's the thing, protection beats sensitivity across a lifetime. The conditions that lighter eyes are vulnerable to compound over decades. UV damage is cumulative. Cancer risk is lifetime exposure. The trade-off of slightly worse night vision for significantly better long-term eye and skin health is, on balance, the stronger hand. Black eyes are the king not because they're flashy or rare. They're the king because they're the most robust, most protected, and most durable configuration the human eye can come in. Nature started here, and for most of human history, it had no reason to do anything different.